Greetings and welcome to Lecture 5.2, Factoring Trinomials. So a while ago we chatted about multiplying binomials. We had something like x plus a times x plus b, and our result, using either our FOIL method or our column method, we would have x squared plus ax plus bx plus ab. Now in the last lecture we chatted about factoring. Therefore, our middle terms, our second and third term, let's factor what they have in common. And it looks like they have the x in common. So that gives us x squared plus a plus b times x plus a times b. If you notice, the middle term, that coefficient, is the sum of a plus b. And the last term, the third term in our trinomial, is the product of a and b. So if we have an idea of how to solve these pretty quickly, we don't need our FOIL method or we don't need our column method. For example, x plus 3 times x plus 4. Well, according to my new rule, I can just say the middle term is going to be 3 plus 4 and our last term is going to be 3 times 4. Therefore, x squared plus 7x plus 12. Let's try another example. X minus 5 times x plus 2. Well, it's going to be x squared, and then it's just minus 5 plus 2, and minus 5 times 2. Therefore, my end result is x minus 3x, x squared minus 3x plus 10. So let's think about reversing the process. X squared plus quantity a plus b times x plus ab would then therefore equal x plus a times x plus b. So let's look at an example. X squared plus 8x plus 12. So I need two numbers to multiply to 12 and to add to 8. So let's check out the factors of 12. Well, 1 times 12, and let's see what else. There's 2 times 6, there's 3 times 4, and since everything's positive, I'm not going to worry about the 12 times 1 and the 6 times 2 and the 4 times 3, because they'll add up to the same thing. So now we have the products all laid out. Now let's take the sum. So what's 1 plus 12? So 1 plus 12 will get me 13. 2 plus 6 is 8, and 3 plus 4 is 7. Therefore, I know my combination that works for this problem is going to be, so x squared plus 8x plus 12 will factor to x plus 2, x plus 6, or x plus 6 times x plus 2, because again, we can multiply in any order and it will still hold true. So that's how we're going to use this nice reversing process to factor a trinomial. Another example, let's factor x squared minus 2x minus 15. Now I've gone ahead and filled in my table, so I have a products that must multiply to negative 15, and the sum must be a negative 2. Well, I have 1, negative 1, and 15. That will multiply to negative 15, but the sum would be a 14. Because it's negative, I even have to try the negative on the 15. So 1 times negative 15 is negative 15, but 1 minus 15 is negative 14. Negative 5 times 3 will get me negative 15. Negative 5 plus 3 will get me negative 2, and just let me finish off the table. 5 times negative 3 would get me a positive 2. So I know my combination of numbers that will multiply to negative 15 but add to negative 2 will be negative 5 and 3. So I know that x squared plus negative 5 plus 3x plus negative 5 times 3. Therefore, I can factor it as x minus 5 times x plus 3. Let's try another example. Let's factor 2x squared plus 10x minus 28. It doesn't look like it fits into what we've been doing, but perhaps we can factor our greatest common factor out first and then work with the process that we've been doing. So it looks like we can factor out the greatest common factor of a 2, and once we factor out the 2, that leaves us x squared plus 5x minus 14. Now I need the product of two numbers to be negative 14, but I need the sum of the same numbers to add to positive 5. I'm just going to write down all of the products that I can with a 14, explicitly a negative 14. So I have a negative 1 and a 14, a 1 and a negative 14. I have a negative 2 and a 7, and a 2 and a negative 7. Now I'm going to just add them up. Negative 1 plus positive 14 is a 13. 1 negative 14 is a negative 13. Negative 2, 7 is a 5. And a 2 and a negative 7 is negative 5. So it looks like the set of numbers I need will be negative 2 and 7. So if you want, you can jump right down into factoring. I don't want to forget the 2. That will be x minus 2 and x plus 7. So I just want to rewrite my original problem. Minus 28, and that factors into 2 times x minus 2 times x plus 7. So when I look at a problem first to factor, there are a couple of things that go through my head. One is, can I just factor it as is? Can I just know what the answer is and write it down? Well, no, not with this problem. Second thing I ask myself is there a greatest common factor that I can remove first and then break it down into what two numbers multiply by the third term and what two numbers add to the middle coefficient? And it looks like I do have a GCF for the problem 3x cubed minus 3x squared minus 18x. GCF looks like it will be 3x. And if I factor out 3x, that would leave x squared minus x minus 6. Now I just need to factor the x squared minus x plus 6 minus 6. So again, products of two numbers that multiply to a negative 6, but they sum to negative 1. Remember, there's an implied 1 in front of the x. So my products of negative 6 are going to be negative 1 and 6, 1 and negative 6, negative 2 and 3, and 2 and negative 3. My sums are negative 1 and positive 6, positive 5. Next is going to be negative 5, 1 minus 6. Negative 2 plus 3 is going to be positive 1, and 2 minus 3 is negative 1. I need a negative 1. Therefore, my combination is right there. Now I can either rewrite it as x squared minus plus 2 minus 3x plus 2 times negative 3, and then pull out what they have, or then break it apart into its factors. 3x, and that would be x plus 2, x minus 3, or if it's just easier for you to jump to the factors because I have them right here, then you can just jump to the factors. So I'm going to leave that up to you as to, do you need to see them middle step and then break it apart, or can you just break it apart into its factors from your table? This problem may not look like our other ones, but it actually is. X squared plus 8yx plus 12y squared. I'm going to treat it exactly like my other problems, even if that number at the end isn't just a constant. I'm just going to treat it like the same way. So I need two numbers that the product of those two numbers is a 12y squared. But I need it to add to an 8y. Now, why did I choose 8y and why did I choose 12y squared? We've always taken the last term, the whole entire term. That's the product. And we've always taken what's ever in front of the x. Well, there's an 8y in front of the x, so I need to add to 8y, but I need the product to be 12y squared. Now, the only way that I can add something is if they're like terms. And if they're at like terms, then each term must have a y in it. So I do know it's going to be something y times something y. But now I break down the 12. 1 and 12. Well, 1y times 12y will get me 12y squared. If I add the two together, that would get me 13y. Let's try 2y times 6y. Well, 2y times 6y, if I add them, that gives me my 8y. So I found my combination, 2y and 6y. So I can break apart x plus 2y, I can factor x plus 6y, and then I'm done. So if you remember, it's the whole entire third term I'm trying to multiply to, and whatever I'm adding to is going to be what's ever in front of my leading variable. My leading variable is an x, therefore it's whatever's in front of the x. Regardless, is if it was written as 8xy, it's still whatever, if you take out that x, it's whatever's behind. That's what you're adding to. So I encourage you to rewatch the video, try each problem yourself, see if your answers match up with my answers. And until next time, be seeing you.